Climate change is one of the most pressing issues facing our planet today. Its impacts are felt worldwide, from rising sea levels to extreme weather events. Understanding how climate has changed in the past is crucial to comprehend the current crisis and mitigate future impacts. The Earth's climate has always been dynamic, but the rate of change we are currently experiencing is unprecedented. This rapid warming is primarily driven by human activities, particularly the burning of fossil fuels. The consequences of inaction are dire, threatening the delicate balance of our planet's ecosystems and the future of humanity. Studying past climate change allows us to understand the Earth's climate system in more detail. We can observe how natural climate fluctuations have occurred over millennia and compare them to the changes we are witnessing today. This comparative approach provides valuable insights into the speed and magnitude of current warming trends. By understanding the long-term consequences of past climate change, we can better prepare for the challenges ahead. This knowledge allows us to develop strategies for mitigation and adaptation. Archaeology, the study of the human past through material remains, offers a unique perspective on climate change over long periods. While history provides written records, archaeology delves deeper, uncovering the stories etched in the earth and the remnants left behind by past civilizations. Unlike instrumental climate data, which only goes back a couple of centuries, archaeology provides a window into climate conditions spanning millennia. It allows us to reconstruct past environments and understand how climate change has shaped human history. Archaeologists act as detectives, piecing together clues from the past to understand how people lived and interacted with their environment. They excavate ancient settlements, analyze artifacts, and study plant and animal remains, all of which can reveal valuable information about past climates. These findings provide a tangible link to past climates and the ways in which humans have coped with environmental challenges throughout history. Archaeologists employ a range of scientific methods to unearth the secrets hidden within the Earth. These methods go beyond simple digging and involve sophisticated techniques to analyze the composition of artifacts, date organic materials, and reconstruct past environments. Radiocarbon dating is a key tool in the archaeologist's arsenal, enabling the determination of the age of organic materials like wood, bone, and charcoal found at archaeological sites. By understanding the age of these materials, archaeologists can establish a chronological framework for past climate events. Pollen analysis provides insights into the plant life that existed in a particular area and time. By studying fossilized pollen grains preserved in sediments, archaeologists can reconstruct past vegetation patterns and infer the prevailing climate conditions. The artifacts left behind by past civilizations serve as tangible evidence of their adaptations to changing environmental conditions. From tools and pottery to the remains of dwellings and agricultural systems, these artifacts tell stories of human resilience and the challenges faced in the face of a changing climate. For example, the types of tools found at an archaeological site can indicate the kinds of resources available and the strategies used to exploit them. Changes in tool technology over time may reflect adaptations to shifts in climate and resource availability. The remains of houses and settlements can reveal how past societies coped with changing sea levels, flooding, or drought. Ancient agricultural practices, as evidenced by the remains of fields, irrigation systems, and domesticated plant species, can tell us much about past climates. Section 5. The Maya Collapse. A stark warning from the past. The collapse of the classic Maya civilization, once a thriving culture in Mesoamerica, offers a stark example of the profound impact climate change can have on societies. Archaeological evidence suggests that a prolonged drought, lasting for several decades, played a significant role in the Maya's demise. The Maya civilization, known for its sophisticated art, mathematics, and astronomy, flourished in the Yucatan Peninsula for centuries. However, beginning around the 9th century AD, the civilization experienced a rapid decline marked by widespread societal collapse. Inscriptions on monuments record dwindling rainfall, while analysis of lake sediments and cave formations confirms prolonged periods of aridity. The prolonged drought had a devastating impact on Maya agriculture, leading to widespread crop failures, famine, and social unrest. Section 6. The Norse in Greenland, a tale of adaptation and abandonment. The Norse Viking Age Scandinavians established settlements in Greenland around the 10th century AD, during a period of relatively warm climate. However, these settlements were ultimately abandoned a few centuries later as the climate cooled during the Little Ice Age. The Norse settlers in Greenland relied on pastoral farming, raising sheep, goats, and cattle. They adapted their farming practices to the harsh conditions, but their survival depended on a delicate balance with the environment. As the climate cooled, the growing season shortened, and winters became more severe. Sea ice expansion made travel and trade more difficult, further isolating the Greenland colonies. Archaeological evidence from Norse settlements in Greenland paints a picture of a people struggling to adapt to a changing climate. Section 7. Lost Civilizations of the Sahara. Echoes of a Green Past. The Sahara Desert, now one of the driest places on Earth, was once a verdant landscape teeming with life. Archaeological discoveries in the Sahara have revealed evidence of ancient lakes, rivers, and lush vegetation, indicating a drastically different climate in the past. Rock art found throughout the Sahara depicts scenes of abundant wildlife, including giraffes, elephants, and even crocodiles. These images offer a glimpse into a time when the Sahara was a vibrant ecosystem, supporting a diverse array of plant and animal life. Archaeological excavations have uncovered the remains of settlements and artifacts dating back thousands of years, further supporting the existence of past human populations in the Sahara. As the climate dried, water sources dwindled, and vegetation disappeared, forcing populations to migrate in search of more hospitable lands. Section 8. From Ancient Catastrophe to Modern Concern. Pompeii and Volcanic Eruptions. The eruption of Mount Vesuvius in 79 AD, burying the Roman city of Pompeii under a thick layer of ash and pumice, is a stark reminder of the destructive power of natural disasters and their potential impact on human societies. The eruption of Vesuvius, while a tragic event, provides a unique opportunity to study the past in remarkable detail. The ash that buried Pompeii preserved the city in a snapshot of time, capturing the everyday lives of its inhabitants. Archaeological excavations at Pompeii have unearthed a wealth of information about Roman life, from their homes and businesses to their art and culture. Volcanic eruptions, while relatively rare events, can have significant impacts on global climate. Section 9. Climate Change and Societal Collapse. Lessons from the Past. While climate change is not always the sole cause of societal collapse, it often acts as a stressor, exacerbating existing vulnerabilities and pushing societies beyond their limits. Understanding the complex interplay of factors that contribute to collapse is crucial for navigating the challenges of climate change today. The examples of the Maya, the Norse in Greenland, and the lost civilizations of the Sahara demonstrate the diverse ways in which past societies have been impacted by climate change. These case studies provide valuable insights into the challenges of adaptation and the potential consequences of inaction. By studying past societal responses to climate change, we can gain a better understanding of the factors that contribute to resilience and those that make societies more vulnerable. This knowledge can inform our own efforts to adapt to the impacts of climate change. Section 10. Predicting the Future. Using archaeology to model climate change. Archaeological data provides valuable input for climate models, which are used to predict future climate trends. By incorporating data on past climate conditions, these models can be refined and improved, providing more accurate projections of future climate change. Archaeological data can help constrain the range of natural climate variability, providing a baseline against which to measure current and future changes. By combining archaeological data with other paleoclimate proxies, such as ice cores and tree rings, scientists can create more robust and comprehensive reconstructions of past climate conditions. These reconstructions provide a broader context for understanding current and future climate trends. Section 11. Conclusion. The past holds the key to our future. Archaeology offers a unique and invaluable perspective on climate change, providing a window into the long-term history of Earth's climate and the ways in which humans have adapted to past changes. By studying the artifacts, ecofacts, and landscapes left behind by past civilizations, we gain a deeper understanding of the challenges and opportunities presented by a changing climate. The archaeological record is a rich source of information, revealing the ingenuity and resilience of past societies in the face of environmental change. By learning from the past, we can better prepare for the challenges of the future and develop sustainable solutions for a changing world. As we face the growing threat of climate change, it is more important than ever to heed the lessons of the past.